Welcome to the explainer. Okay, so in the world of AI, fine-tuning is a word you hear constantly. But here's the thing. A shocking number of people, even really smart people, get the whole strategy behind it completely wrong. Today, we're going to fix that. Right. Let's kick things off with something I like to call the fine-tuning fallacy. It's a myth that's so widespread, it trips up even seasoned engineers.
I mean, the logic seems totally sound, doesn't it? If you want to make an AI an expert in, say, finance, you just cram it full of financial data. Simple. But is that actually the best way to do it?
Well, you might be surprised. The data tells a completely different story. Get this. Researchers discovered that the general, all-purpose GPT-4 actually beat Bloomberg GPT, a model custom-built for finance, on its home turf. Yeah, the specialist lost. This right here is the fine-tuning fallacy in a nutshell. So that brings up a pretty big question, right? If a general model can just swoop in and win, why would anyone even bother to fine-tune? Well, it turns out the real power of fine-tuning is a little more subtle, and it all boils down to one critical limitation. The secret really comes down to scale. Prompting is awesome for showing a model a few examples, but every single model has something called a context window. You can think of it like its short-term memory, and eventually you just run out of room. And that is where fine-tuning becomes your hero. See, it's not about teaching a different type of knowledge. It's about the sheer amount of it. When you've got thousands or even millions of examples, way too many to ever fit in a prompt, fine-tuning is how you permanently bake that skill right into the model's DNA. And this whole idea of permanently changing the model, it unlocks another really powerful strategy, making our models not just smarter, but way, way more efficient. So in 2024, some brilliant researchers figured out how to fine-tune a model that only needs 1.58 bits for each of its parameters. Now, just to put that in perspective, think of a parameter as a little knob inside the AI's brain. Most models use a 16-bit knob, which is pretty precise. This new method, it's like getting almost the same result with a simple on-off switch. It's a massive leap forward for efficiency. And here's the real kicker. As you can see, that incredibly tiny model performed just as well as a model 10 times its size. This is huge. It proves fine-tuning isn't just about teaching new tricks. It's about building lean, mean, specialized models that are way faster and cheaper to run. Okay, so how does this whole training thing actually work under the hood? For all you students out there getting your hands dirty with this stuff, it helps to think of it like you're tuning an instrument. You've got 3 main dials you need to get just right. All right, dial number 1 is the learning rate. This is basically just the speed at which the model learns. If you set it too high, it's going to overshoot the right answer. But if you set it too low, training will take forever. Here's a pro tip for when you're in the trenches training a model. Keep an eye on the loss curve. That's the graph that tracks the model's mistakes. If that line is bouncing around like a pogo stick, your learning rate is too high. If it's just a slow, sad, flat line, it's too low. Let that curve tell you what's going on. Okay, dial number 2 is the batch size. This one's pretty simple. It's just how many examples the model looks at in one go before it stops and updates itself. Think of it as how big of a bite of data it takes before chewing. And the third and final dial is the number of epochs. An epoch is just one full pass through your entire data set. So this dial controls how many times the model gets to see all of your examples. It's all about repetition, repetition, repetition. So a good rule of thumb here is that smaller, more focused datasets really need more repetition for the lessons to sink in. We're talking maybe 4 to 10 passes. But for these gigantic datasets with millions of examples, often just 1 or 2 times through is all you need. So let's pull this all together. When should you actually make that strategic call to fine-tune? When is it the right tool for the job you're trying to do? Here's your strategic checklist. You pull the fine-tuning lever when you need to. 1. Teach a really complex new skill. 2. Lock in a very specific style or format. 3. Train on a massive data set. Or 4. Build a small, super efficient, specialized model. If your problem doesn't fit one of those, you know what? Prompting is probably the smarter way to go. So, the biggest thing to take away from all this is that fine-tuning is an incredibly powerful tool, but it's a scalpel, not a hammer. It's a strategic decision you make when you know exactly why you're doing it. The best engineers don't just know how to fine-tune, they know when and why. So it will leave you with this question to chew on. Now that you really get the strategy, what kind of problem would you want to solve with a perfectly tuned model? Thanks for joining us for this explainer. We'll see you next time.